Okay, welcome back. Here we're going to look at question 15c. Question 15c says three charges R, S, and T are distributed in space as shown in figure 2.2 below. If the magnitude of R, S, and T are given to be 20, positive 20 Coulomb, positive 15 Coulomb, and minus C Coulomb respectively, we have to calculate the force between R and S, R and T. So let us redraw the charge distribution here. So solution. So here is the charge distribution. We have this charge. Here is R. And another charge, the distance from this charge to another charge, T, is given to be 4 meters. And another charge, distance between this charge, R, and charge S, is given to be 5 meters. So it is given that the magnitude of charge R is plus 20 Coulomb and the magnitude of charge S is plus 15 Coulomb as well, while the magnitude of charge T is minus 10 Coulomb. So remember, we are dealing with vector, so it has direction. So the force of attraction, either attraction or repulsion between the charges. So the first question is for us to get the force between charge R and S. Charge R and S. So charge R, let's say charge R is Q1 is equal to plus 20 Coulomb. That is charge R. And let's call charge S as Q2, which happen to be plus 15 Coulomb as well. So here is charge S. So ask yourself, is it going to be repulsion or attraction? Since they have the same sign, positive, they will repel each other. So here, force of repulsion between charge R and S be F1, right? Or FR, as the case may be. So you recall this formula, recall that the force of attraction or repulsion between charge F is equal to Q1, Q2 all over 4 pi E naught R squared. So if we recall this, so you agree with me that in that case, we're going to have this. So you're going to have FR, force of repulsion, will be equal to Q1, Q2 all over 4 pi E naught R squared. So the distance between R and S is 5 meters. So our R is equal to 5 meters. So we'll come back to this place. So put the value, you're going to have, remember you are given that 1 over 4 pi E naught is equal to 9 times 10 raised to power 9 Newton meter squared per Coulomb squared. So in that case, I have FR, force of repulsion, is equal to Q1, which is charge on R, is 20. So 20 multiplied by Q2, charge on S, is also 15. Then multiplied by 9 times 10 raised to power 9 all over the distance is 5. You squared it. So if you ask, why did I say 9 times 10 raised to power 9? Why did I put it in numerator? Remember that this formula, FR, is the same thing as saying 1 over 4 pi E naught multiplied by Q1, Q2 all over R squared. I hope it is taken. So all I just did is to multiply the whole of this one is 9 times 10 raised to power 9 multiplied by Q1, 20, multiplied by Q2, 15. Then everything divided by R is 5. So I will square it. So that's how I got that one. So just multiply 20 by, so I have here to be 9 times 10 raised to power 9 multiplied by, what is 20 by 15? That will give us 300. So we have here to be 300 all over 5 squared, that will be 25. So we have here to be 300 multiplied by 9 exponential 9. That will give us 2.7 times 10 raised to power 12. Everything divided by 25. So when I do it, I'm going to have FR will be equal to, when you divide this divided by 25, you're going to have 1.08 times 10 raised to power 11 Newton. So that's the force between charge R and S. So the question go further to say we should find the force between R and T. So the force between R and T. Here, let's say let K1 here be equal to charge on R, right? Which is equal to positive 20 Coulomb. And let Q2, this is question 2. Let Q2 be equal to charge on T, which is equal to minus 10 Coulomb. Then the distance between them R is said to be 4 meters. So ask yourself, is it attraction or repulsion? Here now, the force between them is force of attraction because it is positive and negative. So let the force between them be Fa, which implies force of attraction, is equal to Q1, Q2 all over 4 pi E naught R squared. The same thing we did, this implies 1 over 4 pi E naught multiplied by Q1, Q2 all over R squared. So the force of attraction between R and T, Fa, will be equal to 9 times 10 raised to power 9 multiplied by 20 multiplied by 10 all over 4 all squared. So we have force of attraction will be equal to 9 times 10 raised to power 9 multiplied by 200, everything divided by 16. So what is 9 exponential 9 multiplied by 200? This will give us 1.8 times 10 raised to power 12 all over 16. So by the time you divide it by 16, we have 1.125 times 10 raised to power 11 newtons. So this is how to tackle this type of question. Thank you for watching. We'll meet in our next class.